So I'm Terry Hardy. I'm a former soil scientist on the Boise and Sawtooth National Forests. And today we're here talking about developing a soil burn severity map, which is used to evaluate our critical values that are potentially at risk from post-fire threats. The pre-fire or unburned fuel conditions guide interpretations for understanding post-fire effects to soils. This includes a live overstory and understory canopy provided by the trees, shrubs, and grasses, as well as dead plant materials. These fuels make up the surface structure and forest floor, or effective organic soil cover, the litter, duff, and woody debris. The type and amount, arrangement, and moisture of fuels burning at the soil surface determines the amount of heat generated and the duration of that heat that potentially impacts the soil properties that regulate runoff and erosion. So in general, we use 5 indicators from the field mapping guide for soil burn severity to develop our soil burn severity map. This is one way of collecting those indicator data. Those indicators include ground cover, ash color and depth, root conditions, soil stability, and water repellency. So with this approach, we can see the amount of organic material that's burned off the top. So we have, a good 2.5 centimeters of duff or litter burned. We still have some recognizable char, but for the most part it's all consumed as ash. It's mostly black ash. And I like to look at these as sequentially, so one builds on the other. If you have a lot of consumption of your forest floor, then you would expect more ash. And then if you have more ash, you would expect impacts to roots and soil structure. Doing this plug in some ways eliminates the mechanical disturbance associated with shoveling or putting a knife in the ground. And also you can get a feel for the root conditions when you start pulling this plug apart, of how much pressure it actually takes to pull the plug apart. And then once we have this apart, we have a clean face to do the rest of our indicators. So we can look at, again, we have our ash layer, our consumption of our organic matter, which is pretty well cooked down, to an inch, 2.5 centimeters or so. And then we start finding some material that's not consumed. And we get into our fine roots, our small roots. And if they're brittle and snap in your fingers, then we have some root impacts and shows higher heat, longer duration heating. Get into the larger roots, if they're brittle or charred, then you have longer duration heat. You start looking at those root conditions, and then you can just make a call on the impacts to soil structure. So with this one, we can't really see too many impacts. We still see fine white roots, which shows some heat duration. And overall, I'd say we can get to our forest floor, our ash color and depth, and our root conditions are somewhat impacted. But when we get down to the soils, it hasn't changed it to a powder, to the mineral soil. It hasn't changed it to a powder or to a single grain as much. There's still small ped-ons of soil that are stuck together by the organic matter that binds them together. So after you break apart your plug and you get a good face, you can do the water repellency, and it's just, you can get it through the entire profile to a depth. And you just drop the water on, and you can see that this is rated as weak. It's less than 10 seconds. There's a couple faces. Sometimes roots, rocks, things like that will hold some of that water in place. But for the most part, it's pretty well soaked in. So weak repellency. It might be a little stronger at the surface, right where the forest floor was burned at the mineral soil. Again, if you follow a sequence or a continuum of forest floor, ground cover, through ash color and depth, root conditions, soil conditions, and water repellency, if you come across some of those that give you a moderate rating and there's nothing else going on, you stop. and then you find another place. But again, you walk around, stick the shovel in the ground, maybe dig another plug out, but look up, look down. What's the variability in that place where you're taking those plugs? So the question is, how much data do you actually need to support running a BARC to a soil burn severity map? And we showed a plug example, and then you start looking around and say what's different or the same around where you're working. There's so much variability. You can have variability in your plug within 20 yards. Again, your data collection comes back to accuracy of your soil burn severity map to reflect what the level of risk is to your values, critical values. If you start seeing similar patterns, you can walk around and stick your shovel in the ground. Does it penetrate the roots? Are you blowing up a bunch of ash? Does it feel like you're walking on a soft pillow with a bunch of ash? Just it's more experience and getting a feel for what you're dealing with as far as that variability. The key is you have a plug at one site, you look up, look around, and get a bigger picture of what's around you.